In this problem, we're told that the position of a particle measured in meters is given by S of t equals 3t cubed minus 4t squared minus t plus 21. We're then being asked to find the acceleration of the particle at time t equals 1 seconds. So what we're going to go ahead and do here is we're going to start with our position function here. And what we're going to have to do is take two derivatives. So we know that starting at position, if I take one derivative, that would bring me to velocity. And if I take one more derivative after that, I'll be able to get acceleration. And this is what I want, right? I want to find the acceleration at time 1. So we start off with our position, s of t, and I'll just rewrite our equation here so we have it. Then I'm going to go ahead and take the derivative to get velocity, right? So it might make sense here just for me to denote this. Take the derivative with respect to t, one more derivative with respect to t. So if I take the derivative of this with respect to t, my velocity equation would become 9t squared minus 8t minus 1. Note here that the derivative constant goes to 0, that'll disappear, and then all of these we just use the power rule on, okay? From here, take one more derivative to get our acceleration, our a of t, and we get 18t when we apply the power rule. Negative 8t becomes negative 8. Great. Now we have an equation for our acceleration. Therefore, if I want to get acceleration at time 1, all I need to do is plug in t equals 1 seconds into my problem. 18 times 1 minus 18. Therefore, I end up with 10, which means my acceleration of the particle would be 10 meters per second squared here. Note that sometimes we'll need to include these dimensions, sometimes not, but the original position was in meters. So let's write this out, meters. If you take one derivative, that means we're finding a rate. So if you started with meters, the rate of change of meters is going to be meters per second. Right? We need to add now a time unit. And then if we did the rate of change of meters per second with respect to time, it would then get another time unit, which means this would be meters per second, or meters per second squared.